Hey Stats class, this is the second allowable technology lab. This one will be more for the final exam because you'll have your technology that's allowed for the midterm already from the technology lab 1. So allowable technology lab 2 starts off with the normal distribution, and I apologize for the length of this lab, but you only have to do one part of this lab. You can do it with the normal CDF on the TI-84, or you can do it with Google Sheets. It's completely up to you. So I have a TI-84 here that I'm going to use for the first part of this lab, and the commands for a TI-83 are the same. There's just one slight little difference, and I'll talk about when we get in there. But at the very end of the lab, I switch over to doing it again with Google Sheets. So you don't have to do the first part of the lab at all if you're going to do the Google Sheets. Okay, you just have to do one part of it. You can do both if you want to decide which one you like better. You just watch this video and see which one do you think you would like better if you do happen to have one of these TI calculators. So the first part of this video I'm walking through with the TI calculator. The second part of the video I'm going to do with Google Sheets. Now there are questions on here that you're going to answer. I'm going to do some of them myself, but when you get down here, the stuff in bold, that's for you to answer. I'm not going to answer those. I'm going to kind of walk you through to see where these numbers are coming from, and then it'll be up to you to complete the rest of the lab. All right, so first of all, as with all of these labs, you want to do File, Make a Copy. All right, I would click Share it with the same people. That way you don't have to add my name at the end. But either way, make a copy so you can edit it and write your answers. All right, so the first thing it says, there's a data set, 12 data points, to enter that in the TI calculator. So the way you're going to do that is you're going to turn the calculator on, second mode if you're in some weird window, clear off the main window, and you're going to hit Stat Edit. So Stat Edit, and you're going to list your values in list 1. All right, there's me typing all the numbers in. All right, I would type them in manually here. If there happens to be stuff in your list, like if I had data points in there, I could scroll up to the very top of the list name, press clear, and then press enter, and it'll clear the list out. All right, clear, enter. Don't use delete, enter. It'll delete your list. You don't want to delete it, you want to clear it. So clear, enter, type all your values in there, okay? All right, if you don't see list 1, you want to press stat, go to setup editor, and hit enter a couple times, and your list 1 will appear, okay? But if you see your list, just stat, edit, type your numbers in there. Okay, so once you've got your numbers in, you want to press second y equals. So there's my second button, y equals, and I want to go in here and turn the stat plot on. So right now mine's already on. If you see off, so if it looks like this, off, you want to hit enter, select on, right, and then select the histogram. All right, all we're doing here is just selecting a histogram. So I want to go over here, hit enter if it's not already selected. List 1, frequency, right, and then you want to press, like it says here, zoom 9. Mine's zoom 9. You just want to hit zoom, and then find, second quit, zoom, and then scroll down until you see zoom stat. All right, mine is 9, so I just click zoom 9, but you can actually scroll down to it and hit enter if you want. So there's my histogram. It's plotted a histogram for me. So the first question's, how would you describe this histogram that your calculator has produced? So I would type in there how I would describe that histogram that I see. Okay, there's a very specific term I'm looking for there that we've already seen this semester. All right, now I want to find the mean, median, and then percent difference of the data set. So to find that, that's just, again, I have my second quit. I'm going to go to stat, calculate, the one variable stat. So I'm going to hit enter a couple of times. So there's my mean. To 2 decimal places it says 383.57, so 383.5, oops. All right, there's the mean. So the median, again, scroll down in the 5-number summary at the very end, 380.5, there's the median. All right, now the percent difference calculation, it says here to make the percent difference based on the mean. So all we need to do is subtract the smaller of the, the larger minus the smaller, or you can do it with absolute values, and then divide by that mean. That's what it means to base it on the mean, is we divide by the mean rather than the median. So when I do this, I'm going to do parentheses 383.57, the bigger number, minus the smaller number, right? And then because I'm basing it on the mean, I'm going to divide by the mean. So that's the 383.57. All right, that's a decimal, so if I want to turn it into a fraction, I just multiply it by 100. All right, so there's the percent difference. So 0.8%. All right, and you can see percent difference, is it close? So less than 5%, so yes. So these are very close, they're approximately equal. They're less than 5% difference from one another. So these two values are very close, and based on what we said for here, what it's saying here is these histograms are typically, when we have a histogram like that, the mean is typically equal to the median. And they're not always going to be perfectly equal, but they're very close. Right? We are very close to these two values being equal. So that follows with what description we gave of that histogram. All right, wants to know the standard deviation. You got to be careful here. Like I said, make sure to pick the correct symbol. Remember on the one var stats, again, I'm going to go back in there. There's two standard deviations. There's one here, the 37.48. There's another here, 36.12. They're both standard deviations, but this is the sample standard deviation, and that's the one we're going to use here. So 37.48. All right, and now we're going into normal approximations on the calculator. So the normal CDF is the number that it takes in a lower number, an upper number, a mean, and a standard deviation, and it gives me the percent that falls in between the lower and the upper number. So what it's telling me to do here is to use my calculator. I'm going to go quit. So it's under second vars, which is DISTRs, distribution, second vars. All right, and then normal, not PDF, CDF. Make sure you're selecting CDF. All right, and it wants me to do my lower number is 300. My upper number is 400. My mean is what I just got right here, the 383.57. And my standard deviation is what I just got right here, 37.48. Okay, now notice this is using population mean and population standard deviation. These are our best guesses for the population mean and population standard deviation. So they are from a sample because there are only 12 data points here. There's way more than 12 of these electric vehicles out there. So this is a sample, but it's our best guess for these two values. So that's why we're using those numbers. Now this is where the TI-83 and the 84 will differ. This is the TI-84. It has this menu where you put things in and ask you what they are. The TI-83 it'll look like what we see with the paste menu, meaning you have to manually put them in, and you have to put them in the correct order. So it's always lower number, comma, upper number, comma, mean, comma, standard deviation. So that's the way that you'll put it in if you have a TI-83, and you just have to put it in left or right, and you don't have that little menu that asks you what's what. All right, so there's what I get when I plug that in, and if you look, that's the same thing that we get right there. All right, then I ask you to press second enter on a TI-83-84. Second enter brings back the last thing you did, and now it makes it editable to where you can get in there and do it again. So I'm going to change this lower number to negative 999. The way I'm going to do that is I'm going to press negative 99, and see it's overriding, and I'm already up to the comma. I don't want to keep putting in values because I'll start getting into the upper numbers position. So I'm going to press second delete, which if you look above it, it says INS for insert, and now that's a cursor on the bottom. It's going to put nines in there and move that comma over as it puts nines in. So just put a bunch of nines in. What I mentioned down here is the negative 99999 is like negative infinity. A positive 99999 in the second position, which we'll do next, is like positive infinity. So there is like a below inequality, less than 400 miles. So roughly 66.94% of all these cars run less than 400 miles on a single charge. All right, now I'm going to do the same thing, second enter, bring back the last thing I just did. I'm going to change the lower number to 250 and make the upper number a bunch of nines. So this is positive 250, so I'll start at the negative, replace all that, comma, and then all these nines all the way up to the end of the 400. So that's going to be a 999 9. Again, it can be just as many 9s as you want, except, I don't want to do just 2 9s here because that would be less than 250. Just a bunch of 9s because it's supposed to be like infinity. All right, mean standard deviation after that. So I hit enter, and again you see that number. This is the probability of being above 200, like an electric vehicle lasting more than 250 miles on a single charge. So virtually all of them are going to last more than that amount. So there's what I mentioned, 99999 with a negative in front of it is like negative infinity. Positive 9999999 is like positive infinity. So we just use those in place of the lower and upper number if we need to go strictly below a number or strictly above a number. All right, now you're going to use what we just talked about here for the normal CDF feature to come up what percent is beyond 380. So 380 or more. All right, what would be the probability it had a range between 150 and 300? All right, what would you do with the normal CDF for that? And then which is more likely, more than 450 or less than 325? Come up with those probabilities, and which one has the higher probability is the one that's more likely. All right, the next feature that we look at on the TI is the inverse normal feature. So right below normal CDF, there's inverse norm. And inverse norm takes in an area to the left of a number. All right, that's very important. It's below the number, and it returns the number that has that value below it. So again, look at this is important for you to watch these video notes this week. But we're talking about a bell curve, and we have some number to the left. Okay, I'm using 25% in my example. So this area is 0.25. The area underneath the entire curve is always 1. So 25% is going to be like way less than half. And what inverse normal is going to do is it's going to tell me what is this number where that area starts. Like what is this value on the number line? The number line left to right is going to have numbers getting bigger and bigger and bigger. But with this mean that we have, this 383-ish number, that's right here. The mean is always right in the middle of the bell curve. It's 383.57. That's the number in the middle here. So this number is going to be to the left of it because it's the bottom 25%. So that's what it's going to give me. It's going to give me the number where that 25% ends, starting in the left tail all the way to that number. The area is 25%. So that's what we're doing on this problem. And it tells me when I plug all that in. So once again, this is under second VAR's inverse normal. The area is 0.25. The mean is 383.57. That standard deviation was 37.48. All right, paste that all in. Again, if you have a TI, you're just going to put it in that order. Area to the left, mean, standard deviation. All right, hit enter, and there's the number it gives me. That is the range that cuts off the lower 25% of electric vehicle ranges from the upper 75%. So meaning 25% of these electric vehicles have a range of this amount on average or less, and then 75% have a range of that or more. So that's the cutoff point. That's what an inverse norm gives. It gives you a value, right? Normal CDF gives you areas or percentages. Inverse takes in the percent and spits out a number. Okay, but it only takes in one number. It takes in the percent to the left. It's very important that we understand that. All right, this wants to know the top 10%. What's the top 10%? So I would do inverse norm. Right, but because it's top 10%, that means there's 90% below it, and that's what I have to put in. I have to put in the number below. All right, the mean is that, the standard deviation is that doesn't change. So there is what I get. There's the 431.6 roughly. Now you guys have to answer these questions in bold. All right, what number, what range, just like we did here, instead of the 99th percentile, the 90th percentile, now we're doing the 99th percentile. The top 1% and the bottom 99%. Right, you need the one that does less than, the below. And then you're going to do the same thing. We already got one of these. You got Q1. But what's the number that cuts off the middle 50%? So between Q1 and Q3, remember, is 50%. That's the box in a box plot. We're trying to find it in a bell curve. In a bell curve, it looks like this. And we want the middle area. We want that to be 50% or 0.5. And we're trying to find both of these numbers. All right, we've already found one. I already did this one for you earlier, so you're just having to find this upper number. Okay, so see if you can come up with a procedure that'll find that. All right, and now we're switching to a Google Sheet or an Excel spreadsheet. So the first thing I do is just give you directly the link to the data set, and this is just a blank spreadsheet, just completely blank, and you are going to go through and follow along with what we just did. So insert a chart. So I'm going to highlight the data, insert a chart. All right, if it doesn't give me a histogram, it didn't, I'm going to select the drop down menu and choose a histogram. All right, there's what it's looking like. It looks kind of like it's skewed to the left a little bit, but if you look at what it tells us to do next, it says go to your customization tools and change the bucket size to 28. And this way it will, so customize histogram bucket size 28. And this way it will match the classes that we used on or the class width anyway, that we used on the calculator. And so when you do it with the calculator, we saw something that looked basically identical, right? The only difference is like the class ranges, 300 to 328. If you press trace on the calculator, you can see that the class ranges are a little bit different with its default setting. But anyway, there is our histogram. So you're answering the same questions. So put this over here to the side somewhere where it can be out of the way, because we need to use these columns beside it. All right, so you're answering that question. How would you describe it? Just like you were doing before in the TI part. If you did the TI part, that's what you would answer there, the description of it. All right, and just like before, we're going to find the mean, the median, and the percent difference. So I'm going to label that over here, mean, median, percent difference. So the mean command is average. This is the same thing that we did on the earlier lab. The median is median. All right, the percent difference, we want to do equals, open a parentheses. I do the bigger number of these minus the smaller number. You can also do absolute value. So equals this minus this, close that off, divided by the mean, because it's based on the mean, times 100. All right, so there's our percent difference. So you can see again, these are very close. All right, is that the case here? Yes, it is, because they are very close. All right, so I would type those numbers in here. All right, so the mean and the median are roughly equal, which again means that it agrees with the description that we give of this histogram. The words you use to describe that histogram imply that the mean and the median are typically equal, and they are. They're only not even a whole percentage point different. All right, we also need the standard deviation. So the next line is asking, what is our standard deviation? So on this next line, I'm going to label it STDDEV, standard deviation, equals, remember we have more than one option. We have these .p, .s. I like standard deviation. If you have, I think, Excel, I think you have to put the .s or the .p now. But I'm going to use StanDev in Google Sheets. Click the cell, the column, and there's my standard deviation. So 37.48 roughly. All right, and then we're just going through here learning how to do probabilities, normal probabilities with Google Sheets. So we need the mean, we need the standard deviation when we're doing this. All right, notice right underneath it's a median. The standard deviation is down here further. So when I want to do a less than probability, I just need a number in the first position, then the mean, the standard deviation, and then the number 1. Make sure the last number is 1. So I'm going to type out here to the side, less than 400. So the way I do it is equals normal DIST right there with the dot between it, or this one. Both of them do the same thing. There's some redundancy here. I always use the one with the dot between it. All right, the value you want to be less than is 400, comma, the mean, I just click that, comma, the standard deviation is next. I just click that. All right, then don't forget this. A lot of people, because that's all you need for normal CDF on the calculator, but you do need to put a 1 here. All right, if I don't put a 1, I put a 0, it's giving me the height of the bell curve at that number. But if I do put a 1, it's giving me the area of the bell curve to the left of that number. So there's what I get. All right, 0.6694 roughly. All right, what does that mean? That means roughly 66.94% of these electric vehicles have a range of less than 400 miles. Right? It was almost the same thing that we got before with the TI. The only difference being we rounded the mean and standard deviation on the TI, and here we clicked these numbers. I just click that cell, and you see it has way more decimal places than 2 decimal places. So that's why we're getting a little bit of a discrepancy. But to a couple decimal places, it matches up. All right, below that, we're going to do 300 miles or less. So I'm going to do right here, instead of less than 400, I'm going to do less than 300. And then the same thing I did here. All right, all that stuff you can literally even copy it. Control C, copy, enter, Control V, and then just change the 400 to a 300. All right, but you can also just retype it in. I know it is some kind of weird formatting there. Default, and it's really small now. All right, that should be fine. Okay, that's weird. I don't know why it changed the size. All right, if you don't like all these decimal places that it's giving, you can highlight the cells that are given too many decimal places, and then just use that button with the single zero. That'll take decimal places away if you only want like 4 or 5 decimal places. All right, the next thing it says is to do a between probability. So there's a couple of less than probabilities. But to do a between probability, we just find those two less thans and do the less than the bigger number minus less than the smaller number. And the idea here is if I have a bell curve and over here is 400 and area is probability here. So this is all the area to the right of 400. And then I do, let's do 300 down here in a different color. So this is 300. And I do all the area to the right of 300. Well, if I subtract the area that's to the right of 400 minus the area to the right of 300, what I'm left with is the area between 300 and 400. And area is probability, so that area would be the probability I'm between 300 and 400. So that's what we're doing with for a between probability. We get a less than a number that's further to the right, a less than a number that's further to the left, and we subtract those areas. So it equals this minus this, and that will be the area between 300 and 400. So in this case, in this application, it would be the probability one of these vehicles lasts between 300 and 400 miles, or has a range between 300 and 400 miles. All right, and then above probabilities, we have to understand that the tool we're using is a below probability. Normal.dist in Google Sheets does below. So it will only find, you give it a number, it will only find the area, the percent that's below that. Okay, but if I want this area that's above it, that's to the right of the number, I have to use the fact that the total area and that the TI will only give me the area below a number, and so then I have to do 1 minus that norm dist, and that will give me the area to the right. If I want area to the right, I have to do 1 minus. That's the big important thing here. Or above probabilities. What's the probability a car lasts more than so many miles? I'll have to do 1 minus. So in this case, this is above, or I think I wrote more than 250. So what's the probability a car lasts more than 250 miles? I'd start off with equals 1 minus, and then type normal.dist. All right, 250 is my number, my cutoff. Click the mean, comma, click the standard deviation, comma, don't forget to click 1, hit enter. All right, turn that off. So there is the probability I last more than 250 miles. So there's that 0.99982 roughly. All right, so you're going to do the same thing to answer these questions. Beyond 380 miles, between 150 to 300 miles, and a choice of more than 450 or less than 325, based on those probabilities, which again are those areas that come out of those normal CDFs. Now again, when I'm doing it in reverse, it was called inverse normal on the TI calculator. It's called normal.inverse on this. So I'm going to write 25th percentile, which is the same thing as Q1. So the way I do that is equals norm.inv, norm inverse. Right, the percent, that's the area. It needs to be a decimal, so 0.25, comma, the mean, the standard deviation. So I click the mean, comma, I click the standard deviation right there, and I get that number. So 25% of these electric vehicles will have a range of 358.3 roughly miles or less. The next thing it's asking me for is the 90th percentile, all right, which means the top 10%. So you might see it written this way, top 10%. Well, that's, again, the right tail. The top 10%, top 5%, top small percentage is going to be up in the right tail. And we, again, the way inverse norm works is we have to give it area to the left. So if this is the top 10% or 0.1 as a decimal, then this is the bottom 90% or 0.9. So 0.9 is what goes in there. It's always the right end. I'm sorry, 1 minus the right end. So the right end is 0.1, 1 minus that would be 0.9. It's always the percent that's to the left. I'm going to write top 10%. So that equals, again, norm.inverse. The bottom 90% is the same as the top 10%. The cutoff would be the same. There's my mean. My standard deviation is right there. All right, so there's that number again. Same thing that we're getting before here, close to what we were seeing with the TI. So using that norm.inv with a spreadsheet, come up with the top, instead of top 10%, top 1%, which would be, again, bottom 99%, or the 99th percentile. And then you're also going to come up with the middle 50%. So that requires Q1 and Q3. All right, you already have Q1, so basically you just need to come up with Q3 for that one. All right, so see what you can do with that. Answer all those questions in bold. You're just practicing going through, getting all the answers that you're seeing along the way. So your sheet should have all that stuff, but you should also have the work to do all your answers in bold in there as well.